Hello everyone, long time no see. It has been a while since we posted anything about the V5 Pro SMT pick and place machine. And to be honest, I think you're gonna like this video if you are using the same machine or thinking of purchasing a similar one. There are some really good stuff. There are some not so interesting, well, not so good stuff. But overall, I think it's gonna be hopefully a nice video, and I think you hopefully like it. So yeah, I mean, basically we talked about in the previous video how to set up the feeders and stuff, and we managed to fix the other bits. But today in this video, we're going to talk about more interesting things and how to get the machine to work for you. And by the way, I don't work for the manufacturers. I basically bought the machine myself and just using it and trying to share my experience on it, and hopefully, obviously, when we put our heads together, great things can come up. Who knows? Anyway, so yeah, the this video is going to be about how you can utilize the machine to make something for you, and you can put how you can put your own design and get it to life. And you'll see. Let me basically take you there and see how it goes. So let's dive into it. Just to let you know, last time we did work on the nozzles bit. We also did work on the faders bits and pieces, but I haven't really touched on how we feed into the machine. So just a quick quick analysis or quick mentioning in here. Obviously, I mentioned that bit. So you put the feeder in place. That's fine. But then that goes here. What we didn't do actually, we didn't take the strip. So to help out understanding the logic of it is, I would basically I found it easier if I strip it off a bit out of before inserting it in, and then slightly shifting it over. I can probably demonstrate that in a minute, but I'm just trying to catch up with bits and pieces. So going back on the bits, I'm gonna honestly, I've not looked at the software. I've not looked at the system for the past couple of weeks. I've been really busy as usual in my life, and also I made a video for the OMAP board received from JLC, which was great. I've not even touched it since that video. Been really busy, but I promise you I'll get back to that, and like I'm actually doing on this machine, the V5 SMT Pro. So first things first, let's just power it up and see what happens. Probably because I've not used it for a while, it's probably going to be an update somewhere. By the way, in case your machine crashes when you use the machine, in case your PC crashes, I found that sometimes with problems with the USB drivers, or if you're using a very long USB cable, you might have this problem message saying USB connection reset. So just bear in mind, if you get that, try to replace your USB with a shorter cable, just in case, to be on the safe side. So yeah, that is one of the reasons why a PC would crash, because it just something goes wrong with it. Anyway, so let's just start this up now. Start. And yeah, as I said, there's a new, like I thought, new version found. So yeah, let's have a look. So quick information, added import optimization page, optimize component package during import. That's nice. I think we touched on that bit last video. They're probably listening to what I'm saying. That's nice. Add an option to navigate or view after placement page. Yep. Top and bottom PCB calibration separately. Okay, optimize panel. Yeah, that is nice. Optimize panel. I was looking for that. That's good. Optimize head changing logic to improve profitability. It will be interesting to find what's in that bag in here. Optimize head changing logic. Is that the kind of the dance between the nozzles. I'm not sure. We'll try that out and see. Optimize placement path. That's good. Optimize table sizing. Blah blah blah. What? Oh my God! Look at that. That's cool. Ah, really, really cool. Thank you. Thanks to the following users for contribution to this release. Heider, Sati. Oh my goodness. I am over the moon. I love you too, guys. Seriously, thank you so much for this. Not very often people thank users. Companies thank users for that. But I mean, that means it's just really heartfelt. Thank you so much. I really appreciate it, and will continue to help more if I can. Just bear with me with the time. I'm always busy with the time. I've got tons of stuff to do. But yeah, I'm touched, really. Thank you so much. Really, thank you. Really appreciate it. So let's just download this version. Continue to read. And 241, 242. Yeah, there's a lot going on. So there's like 3 versions ahead. Fixed penalization. Oh, yeah, that's lovely. So download. Can't wait. I am really super happy about this. So thank you so much for your for thanking me for helping out. Really appreciate it, seriously. So let's go into drivers, and where's it gone? Pick and place. Pick and place machine, and we have V2, was it 24 something? 241, isn't it? Let's have a look again. I'm sure it was 2, we'll say something in here, but I think it's 241. One tip, guys, just in case, if you're watching this video, I'm sure you are now. When you send an update, maybe perhaps best when you compile the system into SMT EZ, maybe it's worth to put the version number in there. It's a minor thing. It's, I still love you. I think I have downloaded V240, I think, isn't it? Let's have a look. So I'm calling it 240. I'm placing it in there, and then we'll see. So I'm just going to close this off. Excuse me. Yeah, I think it's good they speeded up this messages, but just to bear that, just to comment on this, the word "did you know" keep repeating in all screens, and maybe that "did you know" can move into that title here. So tip dash "did you know," and then you can add the stuff in here. So "did you know," and underneath the bulk, blah blah blah, and carry on this way. Just a thought. Just keep saving on the word "did you know," "did you know," "did you know" on all screens. Anyway, waiting for that to connect into the device. So it's not connecting for some reason. Don't know why. Or taking longer time. There we go. Yeah, started. So start. Okay. So we're back in here. Calibration. It's doing the stuff. Let's just record this. Yeah, it's good. All right. Okay. Okay. So in this video, what we'll do, I've got my panels in here. So this is a 6 panel. So you got 1, 2, 3, 4, 5, 6 panels not being cut yet. And the idea for not cutting them, because you can pick and place them easily, hopefully, into well, place all the parts in there. So what we'll do, just to, long story short, remove. I've not have components for this one. This is what shipped with the machine. Probably won't use it yet. Just gonna put it there for now, and use my own one. So that's gonna be probably here, or maybe like this. I'm not sure yet. Yeah, let's jiggle these around. So let's see if I can do it this way, actually. See. Yeah, okay. we should be good. I'm just a bit packed up. There we go. Move that there. There we go. That's good. So now we have the panelized thing in here, and we're going, you know, vertically, not horizontally. So it's important to make sure that it mounts up fine. Sometimes you might need to put some support underneath the board on that section because it's going to, you know, do that and touch it, just in case. But okay, so now we finished the hardware part. We finished setting up the feeder, and we just need to now start telling the system to use that feeder at some point. So let's begin that process. So what we go to here, we go to the part section. Package, as you can see, that's been created for you by the manufacturer, so that's all looks good. Let's just kind of take that down a bit and then get it over. Just gonna slightly increase that down here. Yeah, and by the way, I don't know if you've guessed it, but it's no longer a pink shirt. It's actually a green/blue shirt because I'm having to record that part one more time. The problem is my OBS yesterday kind of failed on me, and that gave me quite a hard time. So I was thinking of kind of editing the video and can get it finished this morning by 3-4 a.m. The problem, as I said, that one of the sources failed from PC. It's always PC a problem. All the hardware stuff, all the MacBook, all works fine. Just the PC always had given me a headache after I record, and it doesn't even show me anything, but it doesn't matter. So we're here. I'm hoping this time things are going to go pick up, and I've got another camera to record the screen like I did on the first video, and we'll take it from there. So fingers crossed. Let's see. So now we're in the system in here, and as I'm just said, we do have a custom set, oh sorry, preset of things where you have the capacitors, you have your resistors, you have your QFNs, you have all sorts of packages. And we are setting an 0402. And I think I've talked about an 0402 in the previous videos a few times, but I don't think people really know what an 0402 is, or what you know, how significantly big deal it is. 0402, I will pick up a sample from here and I'll show you that there. So believe it or not, on my finger there is an 0402 resistor there, and it is literally as if I'm actually holding a grain of salt. I don't know if you can see it well, but just in case people wanted to kind of clarify what that is, this is the 0402, you know, thing in here. You look at it. Just to be on the safe side, I want to make sure that we are seeing this. Yeah, so that's my finger there, and that's the light, and you can see probably reflecting. So anyway, I'm gonna see it's literally a grain of salt, and I'm gonna place it in there. Anyway, so it is tiny, and imagine if you sprinkle salt, you have to get it in one go, and it's not easy. You know, it takes time for soldering on a excuse me, on a microscope. So we are dealing at the moment, I've got a reel down there for my resistor, which is the 0402. So what we'll do, we're gonna set up my package to use the R0402 in here. So what we'll do first, we're gonna go to part, and that's where we're going to get things done. So we click on the plus on that feeder, and here we have a screen that come up to say, what do you want? What feeder? Vision, step, tray, auto feeder. We are using the auto feeder in this video, and just in case you click on this thinking what's going on, why is it not working, blah blah blah, it's also something for the manufacturers to actually really look into. Think about it. You know, the box kind of move and highlight quite nice visually, but when you click it, nothing happens. And the reason because it's that little plus there that might do the thing. And you know, from a visual perspective, from a usability perspective, it makes sense if you could please change that plus or that background of the plus button to a blue or something or red, or even better, make this whole box clickable. So I can click that whole box instead. So I'm going to click on that thing, nothing happens. When I click that plus sign, it works. So anyway, that's the one thing to do. Now we're going to look into the feeder itself. So what we're going to do now is we're going to say, for example, res 1K. That's my 1K resistor, which is set up on the feeder down there. And the packages I was showing you earlier on the previous screen, we're going to use the R0402. And there you can see resistor 1K equals R0402. So that means my resistor on that side is going to use the R0402 on the other side. Brilliant. That's step one. Step two, we need to set up which feeder ID we are looking into. And as I've said in the video here, it's the 615, as you can see down there on the video. So we put down the feeder ID to be 615, and you click that button, and there we go. So now we have the third jigsaw puzzle completed. And what we're going to do, we're going to navigate to this bit in here and make sure that we select, just, on the resistor. So I'm going to make sure I'm selecting that bit down there, which is I have now. So this is now selected. I'm just going to read that camera position, and that's good. And I know from the feeder, sorry, from the nozzle, if I come down, I know I'm about minus 13.9 or maybe minus 14, but I'm going to say 13. I'm going to say minus 14 as the nozzle comes down and touches that. And I've tested that before. Anyway, just let's do this to be on the safe side. Actually, I'm fine. I'm going to use 14 because I've done 14 before, minus 14. So that is that's the first thing to do. The spacing. Okay, now when you set things up, you see those black dots. This is where the gear goes into, and that's what the whole thing spins and then pull the thing off. Now, that question, I know it's not documented, it's not really, intuitive. It is basically suggesting, sorry, one second. It is suggesting that how many of those capacitors or of those components will move when you click that up button. Okay, so what I'll do in here, I know it's going to be 2 of them we need, so we're going to do 2, and you can see that now. So 1 and then 2, and you can see that is spot on. That's how you test it. Make sure you do that 1 and that 2 to make sure that you are actually on the part itself. So that's good. Now we set that thing up, and that is up to you if you want to set it up, but usually it's recommended. So mine is, I've used about 100, say, and the maximum quantity is 10,000 I have on that rail, so that's good. And now I think that's pretty much it. So if I wanted to, for example, test it out, I could just go into here and then say this. Okay, what just happened there, when I clicked that test button, the system picked up the component, went into the bottom camera, scanned it off, and it can see it's nicely and squarely here, and well, nice and square here, and basically it's just asking, is this the right thing? And I can just highlight with a square, is that the right thing or not? So I'm just going to draw a square there to say that's the part there, and actually it's fine, so we're good, and jump to package. So that's all fine. So now pretty much is all set. And if you don't believe me, what I'm doing in here is, as I am clicking, doing this again. If you want to rewind the video, or if you want me to film this, I can do this with the iPhone. I can show you that here. I've added to the video. Notice how the thing is going to pick up the camera. It's going to pick up the component. So I'm going to film up with my iPhone, and then zoom onto it really very closely. So I'm going to repeat that process in a second. So I just wanted you to see it. So I'm going to start that now. See that? Picked it up, it's there, and now I returned it. There. So that is cool. Now we know the pick and place machine works absolutely fine. So, and when we go to the package side, we can see that's how it looks like. So that's all good so far, right? So that's pretty much where we want it to be. And for the sake of this video, I don't want to do every single part for the board. I just want to do these parts one by one. So now this part of the video is now good to go. And now we're going to do is setting up the PCB side. So I hope that kind of initially gives you an idea of how to set your feeders up and how to make sure that they work. One more thing, by the way, before we move on, very, very, very important bit. So notice those up and down buttons, right? If you click the up button, you're going to move by 2. And I'll prove that for you. If I mark, for example, if I go and mark this bit here with a pen, okay, you can see it on the screen. And if I press that forward button, that mark is going to go 2 up, and you can see that there. See that? Perfect. That means 1 and 2. So that looks very, very good. The problem with this system so far is what you can see on the screen in here. Notice, see that is trying to peel off, but it's not really peeling it off. And that's the problem I had with the system so far, and I hope there is a fix for it. I'm not sure. You can see it there on the thing. I can manually pull it with my finger like this. So if I just pull with my finger, there, it's gone off, and now it's okay. But it's not ideal. I'll waste more. Don't worry. I mean, I've got tons of these resistors. I bought them quite cheap, so it's good for me to kind of test with that stuff. But I'll just demo this one more time. If I do press up, you see that sleeve, and I'll press up again, is not right, because now this is now getting in the way of the camera. But you can see if I leave the camera like this on for a bit, it will try to peel it off gradually, but that's not ideal. So I'm going to have to stand up and then kind of peel it with my finger, and it's not good. I think, I've not tried this yet. See that screw in here, this one? I don't know if I could unscrew that a little bit up or screw it a bit down so that it actually adds a little bit more tension on it. I'm not sure, but it is not how I want it to be, and I think it's not, it's not pulling powerful enough, and that's the problem. So if I take this down, peeling it off with my finger again, that's now good again. So minor little things, just keep watch out for, and it's how I can't increase the tension in there. I don't know. I'm not sure about that. So maybe if you can let me know in the comments how we can increase that tension. I'm pretty sure it's one of those. I need to just tune it with the screwdriver. Maybe that will get it to a happy ending. But I don't know. Maybe I've not. I'm just trying to make my video in here. So now, the other bit is, and here is a very, very annoying part. I really don't like that, and I think it's a bug, and if you can confirm it to the manufacturer, please, please, please fix it. That down button, when you try to push the feeder back, if I go forward, you saw it, it'll push by 2. But if I go back, in my head, I expect it to go back by 2. But I'm going to record this, and you can see what happens right now. So I'm going to get my iPhone in there. Put this on video and record, and you'll see in a second when I click the back button. Just gonna wait for that, and here we go. See that? Stop, please. Stop. See? it just gone haywire, just went, you know, lost control, and it's trying to eject the whole thing up, and I just don't get why. So pretty much it'll spit it all out, and I don't really like that because I expect that to go back to not the whole way. Anyway, so you get the idea. That black triangle there, do not click because it'll I don't want to click it because it's not the same as clicking it from here. So I'll click it down there if you like. I'll do that. So now if I click backwards, you see, it's working nice. But I click forward also. It's now tensioning, good. Tensioning more, and that's it, perfect. So one more forward, good, backwards. Yeah, it's going okay. Yeah, but forward, nice, okay. So basically, you can now see the limitations of the system from that point. I think they're easy to fix. I don't know. I hope they are not a bad thing to fix at the end of the day. So anyway, so I'm just really trying to set things up, just making sure that they're all good. Just centering this in the middle, making sure 100% is centered. Good. And we're good to go. So 1, 2, and I think we're perfect. All right, so now the feeder is completely set. Everything looks good on it, and we're happy, good to go. I know there's a bit of a waste, but I don't care. I'm just testing at the moment, so that's fine. As I said, don't click that back button. So now we're going to go to the PCB section. The PCB is where we want things to be. This is our board. This is the stuff we've been working on. I've been working on basically to get my board up and running. So today we're going to use the panelized version. We're going to use the 6 PCB boards. Before we carry on, we need to kind of be aware of the following. If you are using your software, I use EasyEDA. There is loads and tons of software out there. All sorts of companies make PCB designers. EasyEDA works for me really well. I like it, and it does everything I need. So I don't need to really go, and also it's free, so I don't need to go and spend too much money on things I don't need. But anyway, so that's my board, my panel, and as I said earlier, it's 3 by 3, so it's actually 3 by 2, so it's a 6 panel bit. What you need to really work on and make sure that you get things right. If you're using EasyEDA and using this version of the SMD, then you should be fine. But I wanted to highlight what that means. When you export, when you do your PCB, you'll have an option that says generate the pick and place file. And the pick and place file is obviously a set of instructions. It's like a GPS kind of thing to tell the system where the components are from a reference point. So your reference point could be here, and then it starts to go X and then Y, or it can be here and go backward and then downwards and so forth. So each software can treat this differently. And the analogy of it is, for example, in the West, you write left to right. So, you can say here from left to right. In the East, they can write right to left. Which one is right, which one is wrong? There is no right and wrong. They just basically see things differently. That's all I'm trying to say. So this, your software, the designer, they will say, I think the coordinate starts from this side and go increase on that side, and start from here and then increase on that side. But the software will say, actually, no, I think they're going to go from this side and go increase up and then increase downwards. You need to find that out from your software. So EasyEDA, to save your story short, allows you to save in reverse X, reverse Y, default, or mirrored. Don't use any custom settings. When you export the PCB from EasyEDA, just use the default settings. Do not tick any boxes to reverse or change the Y and X, etc., because it is compatible with this one, and I'll explain that here. So now, I've got the PCB file. And what I'll do, I'll actually click that green plus button, import it, import the file, and go into my default. So I saved it here. I got mirrored and penalized and stuff. So I got default CSV, and that's the screen that come up with, which is the components that I'm actually dealing with. I tick that select, obviously select everything one, and what I don't really get on that screen is why there's so many boxes, and if I tick whichever one, they tick them all of them. I don't get that bit. From a design perspective, I just don't think it makes any sense at all. So either one tick box that does it all, or no tick boxes at all. Or I just don't get that, so many tick boxes. And if I untick something from here and then tick that, oh, okay. All right, okay. Interesting. Anyway, so I mean, to be honest with you, I'm going to keep it default. So I'm not going to tick any of those to match up. I'm just going to say, do those please, and get them all in. So that's all I'm doing. So you can see, untick the whole lot. Just tick this thing in here, nothing to match, and then apply. Simple. I just wanted to keep things simple. So here, in the default here, I'm going to call it my board, which I call this the iTaxi call, and then apply. Okay, so now you can see I have imported, you know, a bit of a, so I'm calling it here iTaxi call. Good. And now we have everything where we need it to be, right? So notice there's loads of things to do, and the main thing is, the idea of the whole thing is when you click something, we need it to go and then find it. But right now, it hasn't got a clue because we don't know. It doesn't know where the GPS starts from. It doesn't know where the Earth is based and what it coordinates. So to fix that problem, in the new designs, or what happens after the thing progressed, there's something called the fiducias, and the fiducias or fiducials, they are basically points on the board. So you get a point 1, point 2, point 3, and using that kind of a triangulation, you can say, okay, because I know where this point, where that point is, in reference to the previous to your design, I know where to find the one next to it, or the neighbors, or the 2 meters away, or the next door, sort of thing, because it uses that same kind of mobile signal triangulation. It knows, it goes 3 things, and now it knows, okay, I know where the capacitor is located because I know these points. Now, how accurate can that be? Is how accurate you're going to define it there. So, first things first, let's have a look at the system in here and understand the coordination bit. I need to make sure that you need to understand one thing to begin with. Whereas these numbers, you can see them X and Y. Let me just expand that screen slightly there. Good, okay. You see the numbers in here, X and Y, etc. They will never change. They come part of your design, and they will always be the same numbers. So don't even assume that you're going to calibrate, recalibrate, auto-calibrate, manual calibrate. None of these numbers will change. All what's going to change is the system understanding these numbers. So just bear that in mind. So on that basis, we need to create our fiducia's reference point to say, I want you to understand that that point means this, and that's where it is on the board. So going back to the conversation of, you know, left and right, right or left on the street, where do we go? So on the board, I know, for example, a C1 is, R1 is higher than R2, right? So that means the Y going upwards. And on the board as well, the C10 is after C9. That means the coordination on the X section is going this way. So how the Earth or how the globe works on the pick and place machine, it starts, the 0 point is at the bottom, it goes upwards for the Y, and then right on the X. That's how this is designed, and that's how EDA is designed, and also JLC PCB is designed as well. So bear that in mind. You'll understand that you're in a happy place. So first thing to do, we need to find where the reference point is. And what I'll do initially, I'm going to locate where my board is at the moment. So I need to say, because I'm going to use one board, forget the other 9 because we're only dealing with one board at the moment. So we're going to do the top bit in here. I'm going to do that. And the reference point is going to be here, down there, right? So now we come into this bit. We're going to go into defining where that reference point is. So I'm going to go to calibrate. And I'm going to go to origin, calibrate. Where is the origin? So as I said, you could say the origin is this, or actually this, or that, or that. Our origin in this case is going to be the bottom of board number 1, this one, that point in here, just before, not at the spacing, but just before the spacing, just exactly where the board ends. So we start from here because it's reference to the board. Okay. So let's go ahead and locate our point, and we're going to go this way. We're going, yeah, keep going, and we're going that way. Oops, sorry. No, yeah. So we're going to go to the top first. Right, okay. That's the top, and they're going to go top left, good. And now you're going down, and nearly there, and here we go. Good, okay, so now my bottom design is going to be this guy here, and I'm going to make sure that we get it accurately done. So that's there, that's fine, and I'm happy with that point. So that's my reference point. I'm going to say record it, and I'm going to say 13 point, we said last time 80, please, and are we good? And then apply to current board. Okay, so now we did set our origin. So notice the origin, as I said, the bottom side, and it's going to go X, Y, like that. Okay, and then we click outside, and now we have basically set up where the origin point is. Now, coming down to the fiducia section, how are we going to reference the fiducia? So in your design, pick up 4 components. I'm going to use a square. So 1, 2, 3, 4. 2 top, 2 bottom. Try to go as high as possible and as low as possible for the square, so that actually you can match it up, and then you have a happy ending. You can do a narrower square, which we'll do now in this video, because we have bigger components at the bottom, but that's fine. But at the end of the day, you need to choose as smallest components possible to do that job. If you do anything bigger, it's not going to go as accurate, so just to let you know. So now we're going to specify fiducias. First thing, so what we do in here, we're going to create 4 parts. I'm just going to expand that screen just a bit. And I'm going to say 1, 2, 3, 4. Okay? Or actually, let me undo that. Let me just take those 3 off. I've got a point to make in here to begin with. So delete those, just a second. So I'm going to do this bit in here. Okay? Before I do anything, if I go to calibrate and do a manual calibrate there, notice nothing I can set, and it's very confusing screen. It doesn't tell you anything. It just doesn't make any sense, and I was like, why am I setting default and what am I doing in here? No idea. Just bear with me a second. I've got a doorbell. Right, okay, so yeah, we come back to the same thing. So as I said earlier, that screen we talked about just now doesn't really give much detail. There's hardly anything to do. This one, the manual calibrate, it just doesn't make any sense at the moment. But bear with me, it'll start making sense soon. So right now we just created this part. Okay, so I'll just delete it. I just wanted to take you through it in the nicest way possible. That's not how we should be doing it. So anyway, just one second. Yeah. Okay, so we're going to pick up 4 reference points on the board, like we said. And we want to get this one right. We want to make sure everything's absolutely fine. So what we'll do, we're just going to go up. And by the way, notice my board has no fiducias because it's an old design. And it's, at the time, I didn't really care much about making a fiducia because I was assembling it myself and doing it with a microscope. So fiducias wasn't really a cup of tea for me. So now I understand my OMAP videos have, my OMAP boards have fiducias. But anyway, let's move on. So notice in here R1. R1 is there, and you can see it on that side. So if I expand, just gonna get this right, just go in between, right between the eyes, and there it is. That's R1, you can see clearly, and that's R1 there. And what I'll do, I'm gonna find R1 in here. So R1 is this, tick that, and then copy it, right? So we're gonna copy R1 to another R1, okay? And I'm gonna sort, for the argument's sake, I'm gonna sort by reference, so R1 appears twice. Okay, so R1 is exactly the same component, but this time what we'll do, the second R1, we're going to change that text to say it's actually a manual fiducia. So you've got three sections. Place means it's an actual component. Fiducia means it is a real fiducia on the board generated by the PCB software or EasyEDA. And manual fiducia is like a virtual one we're just creating now. And that's the beauty of the software. I like that because I can virtually specify it and tell it that's my fiducia, right? So now here, fiducia 1, and delete the 1K reference, I don't need it there. It's just, we don't want to see it. Keep the rest, that's absolutely fine. Importantly, keep the coordinates exactly to match R1. And what we'll call this one, we'll call it a fiducia R1, okay? So that should make sense, and notice in here that no longer says red on it. Now all looks green, all looks blue. Now R1 is this, and I'm going to go to the calibrate section. Notice this time the same screen we looked at earlier now starting to make sense. It's now showing FID R1 we just created, and that's the good thing about it. So now we're going to say where I am standing now, pick it up, so do that, okay? So that's my fiducia, R1, and apply to current board. Perfect. Don't worry, what that message means, you need 2 more for the triangle to be able to get the boards fine. But that's enough, that's good. So that's 1. Second point we're going to make is we're going to do, let's just pick up on this D2. So I'm going to go D2. And increase that, and then right between the eyes, and then slightly down, and that's my, sorry, just a bit more, that's my D2. D2, where are you here? You are there. So D2, I've got it, the Schottky diode, exactly. Tick that, and then copy. Yes, please, copy it down there. And now D2, we should have 2 entries in there, so now that's going to be called FID D2. Fiducia D2. Yep, and that's no longer well, it's going to be a blank in here, and that's going to say manual fiducia, right? So that's my FID D2. I'm going to go to calibrate again, and this time my D2, I'm pointing at it, and I'm going to say take it in. Don't click anything in here. Don't need to click current board. I clicked it earlier just to show you the error message so you understand. So just don't click outside it. Done. Now you're going to say bottom points, so you're going to go down, pick bottom points, and I'm going to say this R2 I like. So R2 is this guy here, right between the eyes, good, and R2, we're going to say R2, select, duplicate, yes, and R2 is there. So that's going to be a FID R2. No more that. 1K should go. I don't want to be confused about it. And then fiducia. And then the next one, calibrate again. And then R2, we've taken that in. Good. Next one. 3 is enough, but I'm going to do 4. This time, the 4th one, just to demonstrate to you, you can also select, you know, a rotated item. That is fine as long as you get it right. So, you know, visually, if you're not really sure about this, just make sure. Well, obviously, it's up to you to how to decide. But that should looks good to me for now. The reason I think the corners are all looking equal. Maybe that side is more, but that doesn't matter. I think we're light in the center. So this one we're going to say this is the C17. So C17, we're going to pick you up now and say here that and copy, and we're going down the FID C17. Perfect. That one's fiducia, and that's going to be nothing. Come on, nothing. Good. And now you're going into the calibrate section, and we're telling it this is my C17. And the nozzle, I'm going to say default, that's fine. And now you're going to apply to the current board, and look at that. It's going to say green. I'm happy in a second. There we go. That green is now done. Perfect. And now, look at this. If I go and stand anywhere on the system, there. So now, if I take that down a bit, just expand here. So if I do 1, 2, see that? It's now picking up. That's my Bluetooth HM module. That's my other Bluetooth. That's the 8 megahertz crystal. That's the Atmega. Look at the chip. It's exactly center. Beautiful. Look at that. The 22 ohm. So it's pretty much, you know, got it all right now because of those 4 fiducias. And that is the beauty of it. So everything looks perfectly fine. And everything is exactly how you want it to be. Perfect. So now we have this up and running. We have it working. So I am fairly happy with that. And we can actually now start doing a little test on this and see how things gonna perform. So let's run one. Before we run one, actually, notice everything is red. So we can't test yet because it only knows where the components are, but it doesn't know which way to load them from. So now let's pick up the one, the resistor. The one we did was the 1 kilo ohm. So this is now the 1 kilo ohm resistor, which is R5, and we also have an R2 resistor. They're both 1 kilo ohms, but because of that symbol, you know, I can't type that in, so I'm going to have to copy and paste it. So I'm going to copy that symbol, copy there, sorry, and copy like that. See, this is one of the things in the software. Come on, come on. Control C, fine. I wish I could just, you know, select that copy sound. Anyway, so I'm going to go to back to the part, okay? And now, rather than creating it, calling it resistor 1K, I'm going to paste that there. So Control V. Control V, come on. Yes, so that's the 1K ohm, and then I click that this. And notice the 1 kilo ohm equals R0402. Go back to PCB, and now voila. See that? Now these things have been switched off. You know, 1, 2, and 3 kilo ohm resistors. They're all now they know where to go to get loaded from. So that's a happy ending. So that's perfect. So now let's give it a go and then test our first shot. So I'm going to start this placement. So if I say go ahead, it'll pick up the board and place them where we want them to be. Look at this. Please check the part. So we're going to say I want this, I want that, and that, and that to be placed. So you're going to say yes. So see that now? Yeah, see that? Beautiful. So if I zoom onto it now, actually I don't need the iPhone to zoom onto it, so I can see that there on the system. Because of bouncing back and things like that, it might, you know, might have moved slightly, but I can guarantee what I was looking is actually place them on the right location anyway. So it is there, and if I can to show you that, see that this one here. If I show you, that resistor is actually here, but it's slightly gently bounced back because there's no glue, no solder, nothing to hold it. There's no solder, nothing to hold it. So that's R1. R1 is there. Let's just go to R1. Sorry, just turn that down. R1 is there, R2, and that's also there. See that? It is there, definitely. And R5 is there as well. But you see, it's bounced back a little bit because it's not, it's not, the board can bounce, and because there's literally, sorry, no solder in there to hold it in place. Usually you do the solder, it will not move, So that's now first thing. So now, this is how we set up the board, and that's a successful setup. And obviously, as I said, you can, I'm not going to set up every single tray, every single feeder in this video. It'll take forever. So this is how you set up your feeders, and this is how you get things working from that side. So the rest of the feeders you can set up the same way, guaranteed it'll work absolutely fine. And that's the 0402, and that's beautiful. So now what we're going to do is complete the setup of the whole thing, not just the one board. We're going to do the whole stuff there. To do that, I'm going to say we go in from here. So from that side, we have 3 on the X and then 2 on the Y. So 3 X's and then 2 Y's. And now you can see 1, 2, 3, 4, 5, 6. So that changes the PCB to different thing. So with that here, what we're going to do, we're going to select a manual calibration. Again, so calibrate. And this time we're going to do a panel manual. I don't like automatic. I'm going to do manual calibration. So what is going to happen, we're going to pick up the fiducia reference point. So in here, what I'm going to do, I'm going to pick up on this R1. So the one I created earlier, if you remember, we called it FID R1, that one. I'm going to select this one. And on the top left, I already have it. So if I go to manual calibrate, the FID R1, so go back to calibrate, FID R1 is there. So I'm going to say, take me to it, please. And I'm on that side. So this is FID R1. Don't care about the resistor. In fact, let me clean up that board. I don't want to see anything in there. Yep, good. Right, what I'll do actually, I'm going to replace that board, take it off, and replace it with another one that has a sticky tape on it, so that we see how it works. And when there's a, you see that here, that where I'm pointing the mouse, there's a sticker I have on the board. It's very thin. It's literally the opposite side of a sticky tape, stuck from the bottom side. Or you can use a double-sided tape if you like, that's fine. But that here, once that's placed, it shouldn't move anymore. So just to clarify, that's in the right place exactly, and we're all good. So FID R1 is where we are at the moment, so that's where we are right now. Go to the panel manual calibrate, FID R1, the top left of the board, which means this top left one is where FID R1 is located on the top board is there. So we're going to say that's where it is. Okay. And now FID R1, where is it located? On the top right corner. And by the way, the text for the software developers, please, please, please. Why you have top left and no top left corner when you have top right corner and bottom right? Why do you have the word corner in the middle? It's very confusing. So please, if you are, watching the video, thank you again. Please take up the word corner from one of them, or have all of them saying corner, because they're all, I would suggest top left, top right, and then bottom right. There's no need to put the word corner in there. It doesn't make sense. Also, left, right, you have spelled it with capital L, capital R, but the right in the middle has no capitalization. So just a minor thing. So carry on. Now we're going to do the top right, this one. Forget the word corner, top right. We're going to, where is FID R1 located on this one? So we go in this way, and we're seeing R1, and here it is. So top R1 is actually this one, and we're going to say right in between the eyes, there. Good. So that's my top R1. I'm going to say top right corner, top right basically. And then the bottom right, we're going to go down the bottom right. There. So R1 is this one here. And we're going to say, I can't see that well because of that light. I think it is, let's just double check. It should be on the same, right, R1 is this one. And I'm going to now I'm going to go just click right until to get back to that side of the board. But yeah, that's R1. I can see it now. Sorry. So that's the bit. So now expand with the mouse and double click between the eyes, and now almost done. Just a bit down. Perfect. Now we've got R1 at the bottom, and then we can say take it from there. And now you're going to say apply to all boards, right? Good. Now we're going to come out of this, and now we'll say, now from the top board, I want to say, where is R9? R9 on the top board, there it is. On the bottom board, bottom right, where is LED 1? And there it is. See that? LED 1 is there. Where is H3 on the bottom board? Where is C7? Spot on. Perfect. So now all the boards pretty much have exactly what we want. So now we are ready to carry on and finish this off. So I'm going to go into just to check the nozzle and see you know, where we are at the moment, just to be on the safe side that we have enough. Let me just forward that a bit. I don't like it. So yeah, I mean, that's fine. That's good. So now we'll carry on and we will start the process. So we're going to go to PCB. Now we have enough parts, and now we're going to say, can you please start? And here's the fun. Let's say, oh sorry, package failure, sorry. Because we don't have all the packages, what we're going to do is untick all of them. Just do these. Yeah, the reason we do that because we don't have these components yet, but obviously when you finish your design you would have those completed. Right, so I think now we're good to go. 1, 2, 3, three parts, and now we're going to start placing them down. So start, and yes please, and now we'll start. Let's see how it goes. Oh, there's something not right. Oh, hold on. That thing is not... that tape is not in. No, that's stop. That's not right. See, that's the problem I was warning about earlier. I know, that's fine. Right, so let's just pick up the ones that has been placed up. Let's just double check the board to see how accurate this is. So go to board 1, and I'm going to go to R5. And R5, nothing. Let's say R1, that's nothing. It's not, I don't think it's been placed in there. Nothing in there either. I know why. I can tell. Let me just go into the bottom side of it and then check R1 again here. And there it is. So R5 is good, I think. I mean, that is okay. It's not perfect, but I think I think I know why that is. That's fine. R2, that is perfect, fine. By the way, this one here, the R, where is it gone? R5. It is okay. is correct, because once the solder is here, and if you take that to the oven, it'll be sucked in and welded this way. So that's not a problem. That's good, right? And so the last one, R402, exactly right. Now, this is the best one so far. Well, that's okay. Now, the problem, go into the part, and I showed you earlier, if I go into the camera position, look at that. That's the problem. I don't like it. And definitely, that's not something, you know, it's not a happy ending at the moment. So I'm going to peel it off, pull it. So I can't really pull it with my finger there. So I'm going to have to push it slightly back. There we go. Good. And now tense that in. Yeah. You see that? I don't like it. Yeah, so now I'm gonna center it back. So that is fine. I'll keep it like this. And this time I'm gonna say pick up from here. So we should have enough parts to pick up from now. And I'm gonna say take it from there. Good. Right. The other bit I felt that's not right is when it went to the board, to this PCB here. Where is it? To that PCB, this one. But the height was like gone halfway and thought, oh, it's not that. I'm going to drop it. So calibrate again. And this time manual calibrate, and the 13.80, I don't think it'll apply to all boards. So I'm going to say apply to all boards just in case. And that's now resetting even the Z to be on the safe side. And soon enough we should get that green confirmation and we're good to go. So that's the problem with this machine at the moment, the pulling off the sleeve. I don't like it. I don't think that is right. But I'm pretty sure there's always a fix. There's always a way to get around it, but I don't know yet. So anyway, I'm gonna, if I force the machine to go again, it will probably let me see if I can move those a bit. So I'm going to move the sleeve a bit, just down there. Just to pick it up. I'll rotate that sleeve just in case, you know, so I'm going to rotate it like that. So I've rotated it slightly. Here is the same. So I've rotated it. That's the sleeve. The sticky bit. And I'm going to place that back. So there we go. We're going to start again. And this time, hopefully, fingers crossed, we should be good to go. It wouldn't harm a little test before we go. So select the first board. Where is my, you know, R5? Beyond limit. Oh dear. Why is it beyond limit? Calibrate. Okay, yeah. My origin now is no longer, yeah, I think because I've done it this way. I see. Now let me check this. All boards, hold on. And let me check this one again. Yeah, I see what happened. All right. So because I applied the R1, the whole thing to all boards, that's what I was worried about. So that's fine. What we need to do is redefine. So let's just double check this out first. Go to manual calibrate, and then go to that point where it thinks it is. So that one, you see, C17 is correct. That's fine. So that is the right way. And that is R1. That is correct. These are all correct. All boards, please. What are you talking about? Just going to check this one more time. This doesn't make sense. It takes time to get the green. Just a second. Yeah, green now. Let's see. There we go. It's working again. Excellent. And yeah, that's exactly right. And the bottom board is, where is it? 1 and 2. Yeah, that's all good. So you see what we did? Everything worked exactly as we planned. By the way, that R2 is, the sleeve is a little bit higher than it, so I'm just going to take that sleeve a bit down. Be on the safe side. There we go. I think that's enough. Good. So let's now carry on with this. Excuse me. Now we're going to place it one more time and take it and see what happens. So start again and we'll see. That's one good. So I had to pull that sleeve down. Very good. Okay. Now let's see the results. So now R2 is in place. Perfect on this board. Let's go this way. And what do we have? Yeah, I think that's fine. Let's go to them one by one. So doing that one, R5 is in place, perfect, and that one is good. So the bottom board, where is it gone? Is that there? I'm not sure. Oh no, it's not, because that sleeve is lower than that, so I think it jumped somewhere. But I saw it placing enough. Trust me on this. R1, yeah, next board. I think when I'm making this live, I will probably start with a proper solder in place, because that's the only way to get them fixed. I don't have any faith in that tape. I think it's not working well. Anyway, so I mean, in essence, that video should show you how to use the pick and place machine, how we place the feeders, how we set up the world, how we corrected the stuff, how we ensure we set up the fiducias. So pretty much that is what I wanted to show you today. So it does work, trust me. Sorry. it does work without the word trust me. I think the machine is, I think in pretty much, in fairness, put it this way, the machine is doing the job. It's picking up the item, picked it up, went to the camera, returned it back in the same sleeve, the same location where it picked it up from, i.e. the reel. So we know that works, and but when I'm trying to place it on the board, it's not, and I think that could be because we did not set up the z-axis properly, because I assumed it's 13.8 minus 13.8. That could be the reason. I should maybe either set it higher or lower. If I set it too high, it'll drop it from the sky, and then it's going to go everywhere. And if I set it way too low, it's going to go bounce onto the board, and as the nozzle lifts up, it jumps up and then goes all over the place and then upset all the others. So it's a bit of a balance, I think. You can play with it and make sure that you got the right height. The question is, does it work? Yes, it does. Absolutely works fine, and there shouldn't be any issues with it. The problem I have is with the tape peeler. So when it's peeling off the sleeve, that's not working, and I need to kind of find out what's wrong with it. I mean, it could also be a tape. Well, I'm not gonna blame it on the tape. The tape is a tape. Is meant to stick this way. I don't know if it's meant to be that strong or not. I have no idea. But clearly, the machine should technically peel it off, and it's not doing that. So that's something we need to kind of you know, get down to. Anyway. I hope that video helps. Thank you very much for watching, and probably gonna move on to more. Well, I'm probably gonna make more videos on the pick and place machine at some point, hopefully. But I think more I'm gonna focus on my boards and to what's coming up next on my OMAP design. I want to take that because that's the whole point of me buying this machine. So. Again, thanks for watching. Nice to see you again. Thank you very much for your comments and for your interactions, and I will make more videos. If you have any ideas, want me to make more things and show you more things on the machine, by all means, give me a shout. You know where to find me. I will make videos if it's something, you know, if I accumulate lots of ideas and things, I'll make them into a video and help you out. So good luck and have a nice day. Thank you very much.